Hello everyone, this is your exam 3 review for college algebra. This review is part 1 and we cover problems 1 through. So let's get right into it. We got question 1. Given the function of f of x, write the domain in interval notation. So the domain is all of the x values, and so we need to know what about this function limits the domain. And in this case, this will only be the denominator here. The numerator is just a linear, function, and linear functions go from infinity to, or negative infinity to infinity, so we don't need to worry about that. All right, so we're only worried about the denominator, and it's a polynomial, so that just means we need to find out where it's equal to 0. So we have x squared plus 6, 8, and where's that equal to 0? So we're going to factor that into x plus 4 and x plus 2 equals 0. So x is equal to negative 2 and negative 4. So that means in interval notation, we go all the way from negative infinity to negative 4. From negative 4 to negative 2. And then from negative 2 to infinity. So find the vertical asymptotes of the function. It's kind of the same thing that we did in problem 1. Vertical asymptotes are where the denominator equals 0 because we can't have a function equal 0 in the denominator. So there's going to be an asymptote there instead of a point. So we got to find out where this is equal to 0. So x squared minus 3x 0, and that's going to be x minus 6, x plus 3. So we have vertical asymptotes of x equals 6 and x equals negative 3. Same thing for the second one. And here we have the square root of a negative number. So that means we have no asymptotes because the denominator will never be 0. So we have no asymptotes. All right, and then for the last one, same thing. So we're just gonna factor that into x minus 3 and x plus 2. That equals 0, so our asymptote, x equals 3 and x equals negative 2. So there's all 3 answers for those problems. So find the horizontal asymptotes of the following functions. So the horizontal asymptotes are showing the endpoints of the function. All right. So if we plugged in a very very big value for x, where x is basically infinity or a big number, like this number, right? This x cubed is going to be so much bigger than the x squared because it's going to have the extra set of zeros. Okay, so when we look at the endpoints, we can see that the top will be bigger than the bottom. So that means that this function goes to infinity and there will be no asymptote. Right, but unlike B, this one has no x and this one has x squared. So as we go, the top is going to stay at 2 and the bottom is going to be a very big number. And so that means that as we get a really big number, we're dividing by a really big number, this is going to go to 0. So that means that we have a horizontal asymptote at y equals 0. For C, they have the same powers. We have the squared and the squared. right? So that means when we plug in that number, all the other numbers behind them are going to be irrelevant, and we're just going to be left with 2 times x squared divided by 3 times x squared. And these are going to be these squares are going to be the same number, and that's just going to leave us with an endpoint of 2/3. So y is going to be equal to 2/3. And that is our horizontal asymptote. Alright, for the following function, determine if a slant asymptote exists. If a slant asymptote does exist, find it. Show all work. So what we are going to do is we are going to divide our function using long division. Plus 0. Great. So x goes into 2x cubed to the x squared times. We're going to subtract that and get this down. And then this is going to be negative 4x. Subtract that and get 3x plus 3. Plus 6. Right, so our remainder is negative 3 over x. So that means that our equation ends up being 2x squared minus 4x plus 3 minus 3 over x plus 2. This part here is our slant asymptote, and since this is a quadratic and not linear, and we do not have a slant asymptote. So no slant asymptote. For the second one, we have x squared minus 5 divided by okay. So the first thing we have is we have a 2x here. We get that. That goes to 0. That goes to 3x squared plus 5x, and then we bring down the 2, and that will be plus 3. So 3x squared plus 0 minus 15, and that will leave us with 5x plus 17. So for this one, our equation is 2x plus 3 times plus 5x plus 17 over x squared minus 5, and that means that this is our asymptote. So our asymptote is y equals 2x plus 3. So, question number 5, solve the equations and polynomial inequalities. So this one is just a regular equation, so we can factor them out. This one's going to be x plus 5 and x plus 6, because this will split into 5. And 2 and 5 times 2 equals 10. That means x will equal -5, and -2. So for the next part, we are looking at inequalities of the same polynomial. So since we already know the zeros, we are going to draw a timeline and see what happens in these sections of the function. So if we were to plug in, let's say like -6 to our function, we would get a positive number. We would get we get 4, which is a positive number. So, and if when we're this way on 5, we're positive. When we're in this section, we'll be negative, right? If I were to plug in like -3, I would get -2. Right, and that's a negative number. So, and then on this side, if we like plug in 0, we get 10, so that's a positive number. So we know on this, everywhere before 5 is positive, after 5 we're negative, and then until -2, and then we're positive after -2. So everywhere, so B is asking where we're greater than 0. That's going to be from -infinity to -5, and then from -2 to infinity. So he's asking, or I guess this is where we're equal, so these are going to be brackets, because we're equal to 0 at these points, right? And then it's going to be the opposite for C, everywhere it's negative, which is going to be -5 to 2, -2. And then everywhere we're greater is, now we're just going to use those parentheses. All right. Solve the rational inequality. x plus 1 divided by x minus 5 is greater than 0. So I need to find my zeros, and that's going to be when the numerator is equal to 0. So 1 plus 1 is less than 0. Right, and that's going to happen at -1. Right, so let's draw our timeline at -1. The other thing we have to look for is we have this asymptote, and that asymptote happens at 5. Right, so we have to check around there too. So first we plug in -1, that would be our -2 on, and so that would be negative on top, negative on the bottom, that would be a positive number. If we plugged in like 0, we would get 1/5, which is a negative number. So this is going to be a negative boundary. And everywhere above 5, we're going to get a positive and a positive number. So that's going to be positive. So everywhere we're above 0 is from -infinity to -1. That's actually, we're equal there because that's a 0. And then from 5 to infinity, because that's an asymptote and we can't actually be 5. And that number is not actually 0. So that's the answer to that one. All right. Problem 7 says solve the following inequalities. So we're going to start with A. X times x minus 3 is greater than or equal to 18. So first we're going to start by foiling that out. And then we're going to subtract that 18 over. And then we have a quadratic. So now we're going to FOIL it again. Get x minus 6 and x plus 3. That's going to be less than 0, right? So we have x is equal to 6 and -3. So we're going to check those points on our timeline. So at 6, we have 6 times 3 is 18. If we go to 7, that'll be 7 times 4, which is 28. So this is going to be plus, this is going to be higher than 18. If we're in the middle, we are going to be lower. If we plugged in 0, we would get -3, which is not greater than 18, so that's not true. That'd be a negative number. And then if we plugged in like -4, we get 16 minus 12. That'd be a positive number. Because we get 16 times negative. Oops. We get 10. So that's a positive number. So where are we greater than 18? That is from negative infinity, oops, all the way up to -3, and we're going to include 3, and then from 6 to infinity. So for part B, we're going to start by subtracting the 3 over and getting x squared minus 2x plus 1 is less than 0, and then that means that we can factor that into x minus 1, and x minus 1 is less than 0, and that means that we have x is less than 1. So we draw our timeline, and at 1, and on the left side we have that this number is always positive. If we plugged in 0, we would get 0 minus 0 plus 1 is a positive number. And then if we were to plug in 2, we get 4 minus 4 plus 1 is just 1, which is also a positive number. So the only place where 0 is less than or equal to 1 is at 1. So our answer is just x equals 1. For part C, we have 8 divided by 3 minus 4 minus, so less than or equal to 1. So we're going to start by multiplying our denominator out, and then we're going to subtract over and get 12 is less than 3. And then we'll get that x, that 4 is less than or equal to x. So we draw our timeline, and we have 4. But what we also have to look at is we have to look at our denominator, right? And that denominator happens, or that 0, there's an asymptote there at 4/3. So if we look at our timeline, if we look at 0, that's over here, we get 8 divided by -4, and that's going to be -2, which is less than 1, so that's going to be below. Then we're going to check 2. That will give us 8 divided by 2, which is 4, which is greater than 1. And then if we check 5, we'll get a number that is smaller than 1, so it'll be minus. So that means that our intervals from -infinity to -4, and this is an asymptote. And then from 4, because that's when it equals 1, to infinity, we are less than 1. Then part D, we have 3 over 2x is less than -2 over x. We're going to start by cross multiplying here and getting 3x is less than -2x plus 4. Move that over, we'll get 5x is less than 4, and get x is less than 4 over 5. So we're going to draw our timeline. We're going to have a lot of points. We're going to start at 0, because that's our first asymptote here, and then go to 5, 4 over 5, and then we're going to go to 2. So that's where our second asymptote's at. So we're going to check. So we're going to check to see what happens at our interval. So if we plug in a negative number, this will be negative, and that will be positive, so this will be true. And then on our next interval, if we plug in a half, that will be negative. That will be negative. Plug that into our calculator. 5 divided by 0.5 minus 2 will be negative 2, and then negative 0.2 divided by is negative 4. So that is not right. That is not true. If we plug in 1, we'll get negative 3 is less than 2. That is true. So negative 3 is less than negative 2. And then if we plug in 3, we'll get 3 is less than negative, which is not true. So that means our interval is from negative infinity all the way to 0, and then from 5 over 4 to 2. Also, looking back at this problem here, this is equal to 2x plus 2 over that, FOILed, and so these cancel here, making that a whole. So there would be a hole there, which is not a vertical asymptote, so this is not right. It is just x equals 3. 8. All right, so for number 8, graph the rational function by hand. Fill in all of the blanks. Right, so our domain, we got to start and we got to factor. We have to set, here's our function, and for the domain we have to say where can this function not be x, and that happens in the denominator. So we have to solve our denominator to equal 0 so we can see where it can't be 0. And so that's just going to be x minus 6 and x plus 3. So we're going to have some asymptotes at x equals 6 and negative 3. So our domain goes from negative infinity all the way to negative 3, then to negative 3 to 6, and then from 6 to infinity. So I'm going to go fill that in. Okay, the y-intercepts, that's where the numerator is going to be equal to 0. So 2x squared minus 2 is equal to 0. We're going to factor that x out, or 2x out, and get x minus 1 equal to 0. So we have x equals 0 and x equals 1. So that's where zeros are going to be. Or that's where x-intercepts are going to be. Equals 0 and 1. Our y-intercepts, we're going to plug in 0 for x, and we're going to get 2 times 0 minus 2 times 0 over 0 minus 18, and that's just going to leave us with 0 over negative 18, which is equal to 0. So we have a 0 at a y-intercept at the origin, and that's going to happen here too. Vertical asymptotes, we discussed that earlier. That's going to be at x equals negative 3 and x equals 6. Horizontal asymptotes. So, our horizontal asymptotes happen at our endpoints. So if we looked at this graph, we would see that these have this same degree to them. So we're going to take their coefficients, which is going to be 2 over 1 equals 2. So we're going to have a horizontal asymptote at y equals 2. So now we're going to check to see if the graph crosses the horizontal asymptote. So we're going to plug in 2. We're going to see if 2 for the y. See where that happens. So that's 2x squared minus 6x minus 6. So these are going to go away. And then we're going to move that over. So it's going to be negative 36 is equal to 4x. And that means x is going to be equal to negative 9. So at negative 9 equals 9, that's where the graph is going to cross the horizontal asymptote. So now we have to check for our slant asymptote. And so that means we're going to take x squared minus 3x minus 18 and from 2x minus 2x. So this is going to be 2. So it's 2x squared minus 6x minus, subtract that, and you have 4x plus 36. And so that means here's our slant asymptote, which is just 2. So we don't have one. We just have a vertical asymptote. Right, so let's start drawing our graph. So we have a 0 here and a 0 . We have a 0 at 1 also. And then we have some vertical asymptotes at negative 3. I'll make them red. And at 6. And then we have our horizontal asymptote here. All right, so now we need to plug in some points. I'm just going to fill in this table real quickly with some points. I'm going to plug this into my y equals function. So I have x times, x squared minus 2x divided by x squared minus 3x minus 18. And then go to my table. And so some of my points that I have, let's see, it starts at negative 10. At negative 9, let me go back to blue. At negative 9, I have 2. At negative 4, I have 4. At negative 2, I have negative 1.5. Negative 5, I have positive 5, I have 5. Let's see, at at 7 I have 8.4, and at 9 I have 4. All right, so I'm going to start plotting these points. And then we have -4, 4, so -4, 4, oops, 4. -2, 1.5, so negative 2's out here. We have 5, -5. 7, 8.4, so about like here, and then 9, 4. So this graph roughly looks like this, and it will go to 2 here this way, and then it will come up here through these points and kind of look like that crudely, and then this is going to look like this and go through this point, and then here we'll go back up and just stay right below 2 like this. So that's what your graph's going to look like. None. And yeah, this is part 1. Part 2 will be in the next video. Hope to see you there.